Today we're going to start section 4.1, which is on finding antiderivatives and indefinite integrals. So we're going to start with the definition of an antiderivative. A function, capital F, is an antiderivative of another function, little f, on an interval I if the derivative of capital F of x is equal to little f of x for all x in the interval. So what does that really mean? Let's take a look at the function f of x equals 3x squared. Can you find a function where, if you find the derivative of it, you're going to end up with 3x squared? So think back to when you were finding derivatives using the power rule. The derivative of what thing would give you 3x squared? Think about it for a minute. Let's try f of x is equal to x cubed. What's the derivative of x cubed? And you're all probably screaming at me that the derivative of x cubed is 3x squared. Well, isn't that what little f of x was? Therefore, x cubed is an antiderivative of 3x squared. So the nice thing about antiderivatives is there's a built-in way to check every single answer. Think about what function would have the derivative equal to what you're given. Take your answer that you come up with, find its derivative. If you get what you were given to begin with, then you have the right answer. If you look back at the definition for a second, it says that it is an antiderivative, not the antiderivative. Why is that? I want you to consider what would have happened if we had capital F of x was equal to x cubed plus 8. What would little f of x have been? Keep in mind, little f of x is the derivative of capital F of x. Well, the derivative of x cubed is 3x squared. And the derivative of plus 8 would be 0. Well, that's 3x squared. But this function, x cubed plus 8, is different from the function x cubed. Let's try another one. What if I said capital F of x was x cubed minus 137? What would little f of x be? Keep in mind, again, little f of x is the derivative of capital F of x. The derivative of x cubed is 3x squared plus the derivative of negative 137, which is again 0. So I'm guessing that you figured out, since the derivative of a constant is 0, I could add or subtract any constant I want and come up with an antiderivative of 3x squared. So this brings us to a very important discovery. That is, each antiderivative, in this case x cubed, can have some constant added onto it, and it will still give me that little f of x was 3x squared. This constant is incredibly important when we're talking about indefinite integrals. This constant is always written with a plus capital C, and it's called the constant of integration. By adding it to the end of an antiderivative, you have found the general antiderivative for the function, or a general solution for the antiderivative. It gives you a family of antiderivatives. So let's talk about some notation. If we start with dy dx is equal to f of x, keep in mind that's just saying, all right, the derivative is equal to the function that I gave you. We're going to split it so this says dy equals. So if I multiply both sides of this equation at the bottom of the screen in green by dx, I'm going to get dy equals f of x dx. So it sort of looks like the differentials equation we used to do for dy. What we're going to do now is we're going to introduce what is integral notation. Once I have the dy and the dx separated, I'm going to write in integral signs, which kind of look like squished s's. The antiderivative of dy, well, that's 1 dy. The antiderivative of 1 is a variable. So this is going to be y equals. And then the antiderivative of f of x dx is going to be capital F of x plus c, the general antiderivative. Here are the names for all of these things. The lowercase f of x is called an integrand. It is a function inside of the integral that we're going to find the antiderivative of. The dx that follows the little f of x is called the variable of integration. Meaning we're going to find the antiderivative with respect to, in this case, x being the variable. And we'll see different things written there. We'll see dx written there, dy written there, d theta written there, lots of different things. Capital F of x is your antiderivative. And the plus c is your constant of integration. All right, it's important that you understand these words. So when I say integrand, you need to know that's the function inside of the integral symbol. If I say find the antiderivative with respect to a certain letter, you should know that means there's a d, whatever that letter is, at the end of the integrand. Okay. In the next video, we're going to take a look at some basic rules for integration, and then we'll take a look at some practice examples.